as you saw in my hamfest video, one of the items picked up was this 2-meter amplifier. It's Tokyo Hy Power HL32V, and on the front panel, power switch, power level. Looks alright from this angle, but then when you turn it around, it looks pretty dodgy. Not sure if there is a socket there or a missing grommet, but anyway, that's not there. So it's a power lead. And here, a mode switch, SSB and FM. So it looks like it's been butchered. Here is the specification. It says it's FM and SSB, which is encouraging. 1 watt input, 25 watts output. My main use of the amplifier would be on SSB, so I'll see if I can get it on air and working again. Made in Japan, looks like a really good quality amplifier. Not sure when it would be made, I'd say 80s or 90s. I've got the amplifier set up with the FT817 on 2 motors. These small batteries are powering the 817, but I'll use the larger battery to run the amplifier. First thing is to put the 817 onto 500 milliwatts FM and just check the power with my homebrew RF power meter. I'm not sure how good this meter is on 2 motors, but anyway, this is half a watt. It's 2 watt maximum scale. Half a watt, which is the lowest power setting on the FT817. I'll just go to, and again half a watt on the 20 watt scale. The amplifier puts out around 25 watts, but with only half watt driving, that should be enough under 20 watts to be able to show properly on this meter. Well, that's a good sign. Lights come on. Now this is another switch here. It's a high and low power switch. We'll look at that later on. That's encouraging, and you might even have heard the relay click over. With half a watt going in, we're getting a bit over 12 watts out. Let us boost the power in up to 1 watt. And it goes to over 20 watts. But it is fairly gentle, so I would say it's probably somewhere like 24, 25 watts with 1 watt going in. So that is perfect. The other thing of note is that indicates that the amplifier is most likely linear, which is what we need for SSB. Anyway, I'll just try this other switch on the front panel of the amplifier, this high and low switch. So this is back to half a watt going in, so 12 watts out. That's funny. This other switch does nothing. So there's something defective there. I'll now just go over to SSB. Well, I'm getting it to peak at over 15 watts, but it is clicking annoyingly, and it shouldn't do that on SSB. So it is responding to a signal. There's an RF switch in here that controls the transmit-receive relay, which is fine, but on SSB it's not going to be very good because in between syllables and for quieter parts of your voice, the amplifier will drop out. So there is something wrong in here that is not causing it to work on SSB. But as far as the RF part of the amplifier goes, the amplifying transistor, then that is to spec. That's fine. Half watt going in, 12 to 15 watts going out. Given this amplifier is a goer and a worthwhile project, next thing is to see if we can get a manual that has the circuit. A comprehensive source of manuals is the mods.dk website. Tokyo is right there. Tokyo Hy Power. Now, to actually get a manual, you do need to be registered into the website, and you need to register. You get sent an email and then you can log in. There it is, HL32V. Here is the circuit. The signal from the transmitter is here, or the transceiver. It's just a single transistor for the power amplifier. It's 2SC1946A. Various tuned circuit bits and pieces. And there's the low pass filter here and the antenna connection. There's the transmit receive relay, which, as you heard clicking before, we've established is fine. Now, what else is in the circuit? This is a Section Attenuator. 3 resistors there between high and low, so it looks like that attenuates the power input, which you can select. When it's on high, there's no attenuation, and on low, there's an attenuation. I'm not sure how much it is by. There might be some more information in the instructions. But anyway, one of the things that we found was that there was no difference when flicking this switch. So there could be some issues around this part of the circuit. The thing I'm most concerned about is the FM and SSB. Just having a look there, there's a 3 picofarad capacitor, so that taps off a bit of RF on 2 meters, not very much. Anyway, rectifies it there through some diodes and turns on a transistor switch to actuate the relay there. Anyway, with SSB and FM, the difference is that on FM, this capacitor is not connected. Now, something I should point out about this circuit diagram is that when leads are connected, there is a blob, as you can see at various junctions. Where they're just crossing over like that, their style is that these connections don't exist. So there's no connection between the horizontal and the vertical just here. So on FM, this capacitor is switched out. On SSB, this capacitor, which is, it's an electrolytic capacitor, it's got a plus there, 4.7 microfarad, 25 volt. On SSB, that capacitor is switched in, and the function of that capacitor is to provide a bit of a delay and to keep the relay in between your syllables on SSB. So that is all that switches from FM to SSB. There's no switching of the RF part of the circuit, no switching of the bias to the transistor. So this amplifier is a linear amplifier on all modes all the time, and it's just this switch here that you are switching over to put in some delay for SSB. Then over here there's an LED. Looks like that is, I think it's just a power on LED. Yep, yeah, there's the power supply, the power source here. So the power comes through. Power is always applied to these switching transistors. and when it's on, the collector is also positive through. This looks like a trace. I think it's some form of inductance or strip line, something like that. So that is the circuit of our power amplifier. We know that this part's fine, this part's fine. It's just the input attenuator that's the problem, and also this part around the SSB and then the capacitor here. The transceiver connection, the changeover relay, antenna socket. This is the power. Front panel is over here. The RF transistor is under the board, but it is screwed to the bottom of the case, which is also the heatsink. The circuit board, it's just this brown coloured thing. Don't even know if it's fiberglass. It doesn't look a particularly great board, and we'll take a closer look as things are not quite as they seem. Just looking at this diode, I've got no idea why its leads are so long. Something else I thought was odd was that the front panel, rather than being a proper printed circuit board, is just Vero board, strip board. Is this original Tokyo Hy Power, or was this someone's fixing? If someone else owns one of these amplifiers, then let me know. And another thing that's interesting is a free lead there, so maybe that accounts for the attenuator not working. In fact, just looking at this, S2, R12, well, there's no resistors in these holes there with R12. In fact, there are 3 leads here that are not connected to anything. Another thing that I saw was odd is R9, whatever that is, looks like a bit of a resistor chipped off. Where it would go, I don't know, and there's a link across from there to there. And of course, as you saw before, the FM and SSB switch was removed. Now this part of the circuit looks fairly intact. These are the 2 RF sensor diodes and the 2 switches that switch over the relay. This is the RF output circuitry. So someone has hacked this amplifier to bits. I don't know why. And so that's how it came to be on a hamfest table for $5. Let's see if I can get it to something near its former glory. Looking at some of the features, high-low output power selection. That was that attenuator on the RF input that you could switch in on transmit. That is desirable if you had a higher drive power that you couldn't attenuate and you still wanted to use this amplifier. Doesn't actually say how much, but if it was say 2 or 2.5 watts going in, then you might put in the attenuator, as you can get full output power with 1 watt going in. That doesn't matter so much with the FT817, as it can go down to half a watt or 1 watt, which is what I would be using it to drive this amplifier. So even if I don't fix that feature, then it doesn't matter. Next point is the time constant, and this explains how it works. Putting in the extra capacitor for the extra delay. Just looking a bit closer at the board, that S2 is the SSB to FM switch. So with any luck, if I short them together, I should be able to get the amplifier to operate on SSB and not drop out. I'd like to be able to fix this without having to remove the printed circuit board and get to the underside. So I'll just carefully with a knife just solder these and maybe make a temporary connection, and if I can get the hang thing to work on SSB, then that's half the job done. Just had another thought, and this is introducing my own quick and dirty modification. If I'm not interested in an input attenuator, since I can vary the input with the FT817, then I could just use this front switch to switch between SSB and FM. Then I could just keep these two leads short, maybe even just solder to the back of the switch, and that will make the job even quicker. I've now got S2 temporarily shorted. This should make the amplifier functional on SSB. Now on SSB, now listen carefully and see how the relay responds when I talk. Oh, oh, ah, oh. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. As you heard, the relay held in just like you'd expect on SSB. Now, if we were to go to FM, let's turn down the volume. Again, there's the delay, but on FM you might find the delay annoying if the other person comes back really quickly, so it's good that you can turn the delay on and off. So that has fixed the main problem with the amplifier having the SSB not active. There's also something else wrong here, in that the power LED is not on, but the on-air LED is. When I press, the on-air LED remains on. Arguably, we don't really need a power LED because this lit up switch is red when there's power connected. Yep, I'll just double check. But it's just silly having that on-air LED like that. The more I think about it, the more I think that this has been a bodgy repair. Tokyo Hy Power would have to use a proper circuit board behind the front panel, and they definitely wouldn't have had the LEDs mixed up. Now, to correct this LED, I'd need to change the connections over so that this LED lights up instead of that. So this project has been butchered by someone who doesn't know what they're doing. I'm not sure why. They left it incomplete, and I think they just gave up. And don't forget, there's that loose green wire that is labelled on-air LED. So maybe that is key to fixing this problem. As is this problem down here with R9 that's missing. Just having a look behind the variboard are two 1K resistors. They are in series with the LEDs. I think that explains why R9 was removed. R9 was a 1K resistor in series with the LEDs, or one of the LEDs, and when this bodgy variboard thing was put in, the 1K resistors were mounted on that, so there is then no need for the R9 resistor down here. Something puzzling about this bodge job is that there's a relay. Don't know why. Maybe they thought that it was needed to switch some of the LEDs. Have finally finished the insides of the amplifier. Admittedly, it doesn't look a lot different from when we started, but at least it's working on both SSB and FM. Also, the LED wiring has been tidied up so the correct LEDs light up. And down here, R9 has been put in the correct position. The cord anchoring still isn't great, but at least there's a grommet to protect against the hazard of short circuits. I did damage one of the transistors. I applied some voltage in the wrong place when I was testing the LEDs. Fortunately, it was just an ordinary PNP transistor and a BC558 has been substituted. This is the repaired amplifier. Turn it on. The power light comes on. Currently in FM mode. Now go to SSB. Press the switch into SSB. Oh. There's a good relay delay and the on-air LED is right.
So it's actually hitting the 9 mark on my meter at the moment, so that's what I'll accept. VK3YE, VK3AUQ. Yes, there's certainly quite a significant difference between having it on and having it off, so it didn't seem to make a whole lot of difference to what it sounded like, just that it dropped down somewhat in strength.
It's been a very worthwhile repair. It's taken the best part of a day, but I now have an amplifier that puts out about 25 to 30 watts with 1 watt SSB going in, and it would be just the thing for VHF field days. 90% of the contacts that I make, I won't need it, but there'll be a few cases where I just need to get a bit more power and I can have it at the push of a button. So it's been a fun project and definitely a bargain.